Good morning to one and all. I request everyone to kindly rise and join us in respectfully receiving our dignitary. It is my immense pleasure to warmly welcome our dignitaries to this gathering. To begin this meaningful celebration, let's unite in pride and gratitude as we sing the beloved Philos anthem. I now request everyone to please rise for the Philos anthem.
As Philomena''s we sing, Philomena''s we are. As Philomena''s we sing, Philomena''s we are. Hailing from where the tricks of war, as Philomena''s we stand. Our hearts are not big as Philomena''s we sing, as Philomena''s we sing. Abundantly, blessed by the Almighty God above. In science, the earth, very knowledge we grow. The ocean of wisdom, let it be praised. The words of the world. Was feeling up and fine, but to live a life into benefit all mankind. We do learn for joy, we learn for life. All that comes on our way to bring the stars down on sense each and every day. As Philomena''s we sing, as Philomena''s we sing.
I request our literary and IQAC coordinator, Prof. Sir, to escort the guests. As our guests take their seats, let's reflect on why we are here. Good morning, everyone. I'm Bharat, second year BSc, and I'm thrilled to be your guide to celebrate that magic happens when curiosity meets logic. So, today, February 28th, marks the discovery of Raman effect by C.V. Raman Sir in 1928. Following the theme today, Women in Science. It's a day to celebrate that logic explains our world. But science isn't just about the past. It's about the future, and that future is inclusive. As Jonathan Marr, the Indian botanist, once proved, science doesn't care about your gender, it only cares about your genius. As we move further, I would like to invite everyone. Light symbolizes knowledge and removal of ignorance. Science in everyday life cannot and should not be separated. Said by Rosalind Franklin, as this flame rises, may it ignite the spark of inquiry in all of us. I request our dignitaries to join us on the stage and start on lighting of the ceremonial round. Poetry, the poetry of reality, and song is the poetry of soul. Seek the blessings of the Almighty and set a serene tone for the day. I invited talented students from first and second year BSc for a prayer song. Pray for that soulful prayer song. Before we open our hearts and this evening to our guests, I invite Aisha from second year BSc for the delivered welcome address. Good morning to one and all. It is my great privilege and honor to extend a warm and heartfelt welcome to everyone gathered here today at St. Philomena's College for the celebration of National Science Day 2026. Today, 28th February 2026, marks a special occasion as we come together to celebrate the spirit of scientific inquiry, innovation, and discovery. This year's theme, Women in Science, Catalysing Viksit Bharat, reminds us of the vital role women in shaping a progressive and scientific empowered nation. We are deeply honored to have with us our esteemed resource person, Dr. Krishnaveni S., Professor of Physics, University of Mysore, whose presence adds immense value to today's program. We look forward to her insight and inspiring words. I request Rector Father to hand over sapling to Madam. With profound reverence, we welcome Reverend Dr. Lut Prasad Joseph, our respected rector, whose visionary leadership and constant encouragement inspire excellence and discipline within our institution. Welcome you, Father. We warmly welcome Reverend Father Jnana Pragazam, Campus Administrator, in their absence. We respectfully welcome Reverend Dr. David Sagayaraj S., Assistant to Director, for his gracious presence and continued encouragement. Welcome you, Father. It is an honor to welcome Dr. Ravi J.D. Saldana, our respected principal. Welcome you, sir, in their absence. We extend a cordial welcome to Mr. Ronald Prakash Kutino, Vice Principal, Administration, for his administrative support and valuable presence. Welcome you, sir. We also warmly welcome Mr. A. Thomas Gunaseelan, HOD of Physics and IQAC Coordinator, whose commitment to equality and excellence enhances every academic venture of our institution. Welcome you, sir. And also warmly welcome to Deepa ma'am. It is my honor and privilege to warmly welcome Mr. Arbiter Dominic Royan, Head of the Department of Chemistry and Dean of Science, in their absence. I would also like to acknowledge and welcome all the faculty members, organizing committee members, students and guests who have gathered here today. Your enthusiasm and participation are what makes events like this successful. I heartily welcome Mr. Sachin, sir. Let us use this occasion not only to celebrate scientific achievements, but also to ignite curiosity, encouragement, innovation, and inspire the next generation of scientists. Once again, I extend a warm welcome to each one of you. Thank you for joining us, and I wish you all a very enriching and memorable National Science Day celebration. Thank you. Thank you, Aisha. I welcome you too. Success is best measured by progress. To share the milestones our department has achieved this year, I invite a PGE student representative, Nitya from MSc Physics, for the report reading. Over to you, Nitya. A very good morning to all, respected dignitaries and end of the dais. It is my privilege to present a brief report on the National Science Day 2026 celebrations being hosted by the PG and UG Departments of Physics and the Internal Quality Assurance Cell of our college. As we commemorate this year's theme, Women in Science, Catalysing Viksit Bharat, we have organized a series of competitions designed to spark scientific curiosity and innovation among the student community of the University of Mysore. The events began successfully on the 20th of February with Kannada and English essay writing competitions, where students thoughtfully engaged with the provocative topic, "Can technology replace human intelligence?" The quality of writing and the depth of thought displayed were truly commendable. On 21st of February, we witnessed the poster making competition. It was inspiring to observe participants creatively depicting women's contribution to global science, bringing to life the significant yet often under-recognized role of women in shaping the scientific world. Looking ahead, the final and most dynamic event, the working model making competition on the subject of general science, will be held on the 14th of March. Following the grand success of last year's exhibition, which saw over 40 innovative models and was visited by more than 500 students. We eagerly anticipate another showcase of creativity and interdisciplinary collaboration. Last year's event also saw wonderful participation from departments like immunology, chemistry, and botany, making science accessible and exciting for all. I extend a warm welcome to all participants from various colleges and encourage everyone to make the most of this platform. A gentle, a gentle reminder that spot entries are still encouraged for the upcoming model making competition. Let us uphold the spirit of inquiry, maintain the decorum of competition, and celebrate the power of science to build a Viksit Bharat. Thank you. Thank you, Nitya. I'm reminded of Mary Curie, who said, I was taught the way of progress was neither swift nor easy. To those receiving awards today, you have proven that the not easy path is the most rewarding one. Now comes the moment of appreciation. To reward the hard work and brilliant minds, we move to the prize distribution session. I invite Chandana Ma'am, Assistant Professor from the Department of Physics, to announce the winners of the Kannada essay writing, English essay writing, and poster making competitions held in the view of National Science Day. Over to you, ma'am. Good morning, everyone. On this special occasion of National Science Day, we came together to celebrate the spirit of science and innovation. It's a day to encourage curiosity, learning, and creativity. Today, we are here to recognize the hard work and talent of our participants in the essay writing and poster making competition. Each one of you has shown a great passion and a dedication, and we are proud of your efforts. Now, let's take a moment to honor the winners. I request Dr. S. Krishnaveni ma'am to come forward and distribute the certificates for the winners. The first prize in the Kannada language essay writing competition goes to Rajesh N. I request the winners to please come up on the stage and collect the certificates and prize. He is from Yuraja's College. And the second prize goes to Ophelia Pushpa from St. Philomena's College. And the third prize is shared between two participants, Siddharaju PR and Rajesh M. Thank you, ma'am. Now I request our respected rector to come forward and distribute the certificate for the winners. Now it's time for English essay writing winners, and the first prize goes to Spriha K. She is from St. Philomena's College. And the second prize goes to Kirtana Girish from the St. Philomena's College. And the third prize goes to A. Aishwarya from St. Philomena's College. Thank you, Rector. Now, I request Dr. Sadairaj Father to come forward and distribute the certificates for poster making competition. The first prize is secured by Parinita K. from St. Philomena's College. The second prize goes to Ophelia Pushpa J from the St. Philomena's College. And the third prize goes to Dhanushri B from St. Philomena's College. Further for distributing the certificates. Congratulations to all the winners. Your achievement inspired us all to keep exploring and learning. Keep up the great work and continue to fuel your curiosity. Thank you all and enjoy the rest of the day. Thank you, ma'am, and congratulations to the winners. Now, I would like to invite final year students from Criminology and Forensic Science Department to represent their software front-end web page of phishing and wishing. Good morning, everyone. We are from BSc final year. We have created a web page based on phishing and wishing. Here we have used HTML, JavaScript, CSS. Here we are trying to show you how hacking is done on phishing and wishing. And we are trying to show also the prevention. What and all prevention we can take. Here we have shown you one live prevention. Okay? So the from phishing we will start. Phishing. So and anyone knows what is phishing? Yeah. Phishing is sending malicious messages through emails, SMS or OTP through your system. It might be a laptop or something, any device. So through that they will try to hack your system and try to take your data or anything. So here we'll show you a live example from the hacker panel and also the victim panel. Hacker panel is how the hacker is doing. That and all will be shown here and how the victim will be displayed. And this all will be shown here. So let's start. First the hacker, that is the hacker panel on the corner. Next to that is the victim panel. Through the hacker panel, the hacker will send a phishing email or SMS. It might be both. It might be email or SMS. First, as it has sent, there you can see it is showing. The message has been sent to the victim. Go to the victim panel. Yeah. So there it won't send them like normal. They will pretend to be as someone important. Like from your bank, like a KYC update or Aadhaar update, something related to that. So once you are, like it is something important, what you will do? You will try to fix it. So the victim is trying to fix this. Victim will verify the account. Like the example they are saying to do the KYC update. You have to verify your account there. The victim has verified the account. Once he has verified, you can see. The hacker can see that the victim has clicked on the malicious link. What and all he has sent. Once he has clicked, go down. He need to establish the connection. See, there it is disconnected. Once he has started to establish the connection, go up, victim panel. Now again he will send a message like you have to verify your email, your password or something, like something important, account number, last four digits of your account number, OTP, it might be something like that. Once it has verified, you can see verified. Login. Go to the victim panel. Login. Once you have login and verify his account, then you can see hacker panel. Go down. There he has login and verified. Everything is visible there. Now the what and all information he needs. Example, your email, your password, and all. It will be displayed there to the hacker. This is what the hacker can see in his system. We are showing this part. Next, he need to extract the data. He will extract the data from your system. Extracted. He extracted the data. See, there. Again it showed. Extracted the data. Once it has been extracted, he will try to remove the connection. He wants to erase all his evidence. This is, again I'm saying, this is from the hacker side. This is all it's happening from the hacker side. Once he has taken the information, he will clear it. Once it has been cleared, now what the hacker thinks, like if the information has been cleared, no one can trace him. Nothing will happen. But there is computer hacking investigation officers in our cyber crime where they have the authority and permission to extract back the evidence. What and all data they have taken, what and all data they have stolen, or what and all it might be. Here one disadvantage is like the location. Sometimes location we cannot trace it. But other than that, all the data and what and all, at what time we have took, everything we can see here. See, once we have extracted, there is an option in our system where we can extract the data from the CHFI panel. Open it. It will show you the exact time, what data they have stolen, how many times they have sent you the message. Everything will see. The time at the most up corner, the time, the date, what data they have stolen. Go down. Example, we have gave you example of your email and your password. Email is very important. For most of the apps, email and password is must. So if they got the email and password of your account, then they can try to do what and all they want. In many apps, it is there. So there we have only shown you the email and password. If you want, we can also generate the report. This is the report. This is for the victim's sake. Like if you want to go and complain for the in cybercrime and all, so we can generate the report also here. If you want, we can download. Otherwise, from here only we can give him the copy. So this is how the hacking is done from the hacker side. So this is there. For this, we have created a live prevention. For example, see, we will keep the passwords, patterns and all. Numeric or alphabetic numbers we will keep. But it is nowadays it is easy to hack. It is very easy. We are not saying to remove that part, but it should be there. With that, you have to add one more prevention. That is the puzzle. In this puzzle, we have only showed you the letters or something here. Here you can also add your photos, your favorite books. This is a puzzle like where you only know this one. Example, hello, St. Philomena's College I have given them. If you don't know, here simply I am showing you. It is very simple for your understanding. But there, what and all you want, you can keep. Like your book's name. There are 5 books. You only know the order. Like this book comes and this book comes second. So this is also one of the preventive measure. If they cannot, if they have hacked your password or something. But if they are not able to crack this one, they cannot go further. So in this software, in phishing, we have shown you the how hacker will hack through hacker panel, then the victim panel, then the CHFI panel, and the puzzle. This is about the phishing. The puzzle is very important because it is easy to crack nowadays. Your password and your patterns, it is very easy. So we are telling through our work, we are trying to save you all to add this prevention. Over to Harini. Now she will explain about the phishing. Have you know about phishing? Phishing means calling. Now, hackers have tried to call, trap, or a bank employee and ask the details, account number, password.
I need to verify your identity. Can you provide your full name, date of birth, and last four digits of SSN?
My name is Ronnie Sharma, job March 15, 1990, SSN last 4 6789.
Thank you. Now I need your account number and online banking password.
Count 987654321. Password SECURE Pass 123.
Perfect. Your account is secured. Goodbye.
Simulation started. Ravi is calling. Make answer. Simulation stopped. Simulation started. Ravi is calling. Make answer call.
Hello Ronnie. This is Ravi from SBI Bank Security. We've detected unusual activity on your account.
I'm hanging up and calling SBI. Simulation stopped. Simulation stopped.
Hello Ronnie. This is
Warning automatic alarm. Suspicious score reached 5. Alarm activated. Next,
Thank you. Ravi. What?
white hesitate mark police. Ronnie. Simulation stopped.
Company as well as my Thank you for your presentation. Also, to mention, there are some pictures displayed outside the auditorium from Criminology Department uncovering the truth behind the tape, witnessing the signs, systems, and stories of criminal justice. Please do witness how forensic evidence turns a silent crime scene into a powerful narrative of truth. Moving further, we are privileged to have our rector with us today. I invite Dr. to share a few words of wisdom and guidance with. Over to you, Father.
This host person, Professor Dr. Krishnaveni, members of the teaching faculty, dignitaries of the guys, and my dear students. Good morning to all of you. I'm really excited to see so many students here, the Department of Physics. I'd like to congratulate each one of you, especially the first years. There are so many of them, isn't it? I'm not excited with my words. No? Good. Anyway, I'm really happy that in our college today we are having this National Science Day. So the physics department led by our beloved Gunashilan and Sachin, we have taken a lot of trouble to organize this day, and we have invited an eminent person from the University of Mysore, Professor Krishnaveni. I'm really happy that we invite such eminent people to address you. The reason behind that you get inspired by such persons their studies, their research, their achievements, how they make a big difference in the lives of so many students. That serves as an inspiration to all of us. That's the reason we invite such eminent persons to address our students. I take this opportunity to congratulate all the winners of various competitions and also the wonderful presentation that our students prepared. I think I belong to the old school. Many things I find it difficult to, but I'm very careful. I hardly use accounts. I hardly keep my money in the bank, so I'm not afraid. That's the way I save myself. Okay? And anyway, this is not an advice to all of you, but that's the way I keep very little. I have very little. I keep very little there in the bank, and I hardly do any transactions. So that's the way I save myself. Anyway, I really appreciate the students for all your cooperation, for all the goodwill that you manifest in running this institution. Congratulations to all of you, especially to the HOD of the Department of Physics. So have a wonderful time.
We thank you, Father. I now request our chief guest, Professor Krishnaveni, to administer the pledge.
Good morning, everyone. There is a pledge in Kannada. I'll just read out. You can repeat it. Please your hand like this. ನಾನು ಭಾರತೀಯ ಸಂವಿಧಾನದ 51A(h) ವಿಧಿಯ ಅನ್ವಯ ವೈಜ್ಞಾನಿಕ ಮನೋಭಾವನೆ ಮತ್ತು ವೈಚಾರಿಕತೆಯನ್ನು ಬೆಳೆಸಿಕೊಳ್ಳುತ್ತೇನೆ. ನಾನು ಪ್ರಶ್ನೆ ಮಾಡದೆ ಯಾವುದೇ ತರ್ಕ ಒಪ್ಪುವುದಿಲ್ಲ ಹಾಗೂ ಸಂವಿಧಾನದ ಮೂಲಭೂತ ಕರ್ತವ್ಯದ ಆಶಯದಂತೆ ಮೌಢ್ಯತೆ ಮತ್ತು ಅಂಧಕಾರವನ್ನು ನಿರ್ಮೂಲನೆ ಮಾಡಿ ಜೀವ ಜಗತ್ತಿಗೆ ಪೂರಕವಾದ ಬದುಕನ್ನು ರೂಪಿಸಿಕೊಳ್ಳುತ್ತೇನೆಂದು ಈ ಮೂಲಕ ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನದಂದು ಪ್ರತಿಜ್ಞೆ ಮಾಡುತ್ತೇನೆ. ಜೈ ಭಾರತ್, ಜೈ ಕರ್ನಾಟಕ, ಜೈ ಸಂವಿಧಾನ, ಜೈ ವಿಜ್ಞಾನ.
Thank you, ma'am. Who will we hear from our keynote guest? Let's get to know them better. I invite Bilrish from the second year BSc to introduce our distinguished speaker. Over to you, Bilrish.
Good morning to one and all. My Prof privilege introduce our distinguished guest, Dr. Mrs. S. Krishnaveni, Professor of Physics, Department of Studies in Physics, University of Mysore, Manasa Gangotri, Mysore. Dr. Krishnaveni completed her MSc in Physics in 1997 with first rank securing 82% and was awarded 4 gold medals from the University of Mysore. She cleared the KSET examination in the same year, went on to complete her PhD in Physics in 2003. Under the prestigious CSIR Research Fellowship, she later served as a CSIR Research Associate as a postdoctoral fellow during 2025-2006. She began her academic career at Maharani's Science College for Women through KPSC recruitment and later joined the University of Mysore in 2007 as assistant professor. She has been serving as professor in physics since 2021. Notably, she created history as the first woman chairperson of the Department of Studies in Physics at the University of Mysore, serving from February 2023 to February 2025. Professor Krishnaveni is a passionate teacher who has handled major subjects including mathematical methods of physics, classical mechanics, quantum mechanics, nuclear physics, reactor physics, accelerator physics, biophysics, and numerical methods. Her research interests cover diverse and advanced areas such as radiation-induced effect in semiconductor device, molecular dynamics, simulation of bimolecular mechanism, gamma ray sheathing materials, and fabrication of triboelectric nanogenerators for energy harvesting. He has published more than 110 research papers in reputed international journals, including high-impact journals like Nanoenergy and Chemical Engineering Journal. He has also filed a patent in 2024 related to triboelectric nanogenerators with a height index of 22, I-10 index of 33, and over 1,800 Google Scholar citations. Her contribution to research is truly commendable. He has guided 7 PhD scholars to successful completion, and currently 5 PhD scholars and 1 fellow are pursuing research under her mentorship. She has handled several major subjects funded by IUSC, UGC, DST, SERB, and CSIR, and recently a prestigious DST, SERB, SURE project in the field of biophysics. He has delivered invited talks across India and internationally, including visits to countries such as Italy and Thailand. In addition to her academic excellence, she serves in administrative roles at the University of Mysore, including coordinator of the Intellectual Property Rights Cell and chairperson of the Internal Complaints Committee, among many other responsibilities. We are indeed honored to have such an accomplished academician and researcher amidst us today. Madam, we extend our warmest welcome to you and thank you for gracing this occasion with your presence.
Please join me on the stage for the felicitation. Thank you, dignitaries. I now hand over the microphone to our guest speaker for their address. Over to you, ma'am.
Good morning, one and all. Hope still we are in the morning. About to become afternoon, right? So I wish you all a very happy Science Day. There is no jokes? Yes. And also today's theme, all of you know, right? So women in science. So all the women should be like very enthusiastic, and also of course the boys, right? So yeah.
Let me start my presentation. So I'm not giving you any physics presentation. Don't worry. Because as physicists, I think we'll take examples from physics. That is inevitable. But still, the entire motivation behind preparing this lecture is to just motivate you to take up the science. Because these days, you all know, I mean, people who are coming to the basic science is gradually decreasing. So we don't know what is the exact reason. Many reasons are there. Okay, so we cannot discuss the reasons. Rather, what we can do is we can get motivated so that, I mean, the people who are gathered here, maybe MSc, BSc students who are very young, they can take science as well in their future studies. Yeah. So I'm going to talk upon the scientific temper for a Viksit Bharat, because you know, so the whole theme is to just get a scientific temper and to, I mean, increase the research in the science. That is very, very important. So first of all, I'm going to talk, I mean, start with the famous persons of C.V. Raman, because you all know why we are celebrating, I mean, National Science Day. I hope you are all knowing, right? So how many physics people are there? How many biology students are there? Maybe some 50-50. I don't know. But anyway, I have been told that many of you are from physics background, and I mean, equally there are some people from the biology background. Even if there are, I mean, people who are not, I mean, studying science, it's okay. Okay. So I'm not going to give you any particular talk on any theory of science or the physics. Okay, so yeah, you all know why we are celebrating National Science Day. Why we are celebrating? Initially also your, I mean, anchor told that. Why? Because today is the day when the, I mean, in the February 28th, in 1928, Raman has announced his Raman effects, right? So that is why we are celebrating the Raman, I mean, Science Day in India. And why we are, I mean, Raman actually was traveling on the boat, okay, so in the ship in the sea, and he was just asking a question, why in color of the water is blue, okay, and by that time Rayleigh has explained that effect as a Rayleigh effect, you know that. So since sky is blue, since water is reflecting that color, so that is why the water is also blue in color. But he was not convinced with that answer. So he was just asking why. I mean, he was not convinced with that answer because he wanted to know what is happening at the molecular level. When light interacts with the water, what is happening in the molecular level? And he was not just convinced with the fact that the, I mean, whatever the air molecules scatter the sunlight, and also that is why it is, since it's going to be reflected in the water, so that's why water is also getting the blue color. He was not convinced with that. So the whole world has convinced, but he was not convinced with that answer. So what is a scientific temper then? So how do we develop scientific temper? That is why I have taken this example. Science begins not with the instruments, with the doubt. Okay, so when we ask valid questions, okay, so when we have questions in our mind, okay, so then only we will get the answer, proper answers for those questions. Not just by asking the questions, so we have to learn, okay, so learn through reading and doing some small experiments. So therefore, according to, I mean, whatever the C.V. Raman effect, it came because of the curiosity of the C.V. Raman. Okay, so that was a very simple question that was striked his mind and he worked for it. Okay, so that's why there is a discovery of C.V. Raman. Okay, so he was questioning the color of the sky, sorry, color of the sea, and also there was a, I mean, even though he was not in any like European country or the American country where the sophisticated experimental facilities were available. So during that time, during 1928, you can imagine, so we were still in a very bad condition as far as scientific innovations are concerned. So he has used a very, very simple experimental setup. Okay, so that is shown in this particular figure. So there was very, very limited sources and very, very simple apparatus, and but he had a greater focus on the performing systematic optical experiments, and that is why there was a breakthrough, and he demonstrated the Raman effect in 1928. So here there was a discovery that light changes whenever the light interacts with the matter or the molecules, it's going to change its wavelength. It's not going to scatter its own intensity or the wavelength. Rather, there will be a, there will be a production of the light with the lesser wavelength as well as the larger wavelength. So that was the, your Raman effect, and that actually shown molecular fingerprint method. Okay, so don't think Raman effect is a very, very simple effect. It's a very, very great effect, and people are going to use it to find out the molecular printing, okay, so, or to identify a particular elements, okay, so in the material. And this has changed the, globally, okay, so what is the Indian picture in a global map? So that actually gave a very good impact on that. And we all know in 1930 he has won a Nobel Prize, right? Immediately after the 2 years, he has been awarded with the, he was the first Asian to get the Nobel Prize, and he remained the first, only Asian till today, okay, so to get the Nobel Prize. Okay, so, and also this discovery was, not just in physics, okay, so it was a greater discovery in all these fields. I can say that this discovery was a greater discovery in the science itself, not in just physics or biology or the chemistry. And what you can understand about this discovery is just to have a scientific temper. So you have to begin to ask questions or to think about the nature. So if you ask proper questions, I think C.V. Raman only have told in one time that if you ask a proper question, so nature is going to give you a proper answer. Okay, so you have to ask a proper question. Okay, so proper is to be like in the inverted comma. So that is very important. Okay, so these are the pictures from the, C.V. Raman lab. He is a C.V. Raman from his lab, and also in his old ages. Okay, so the next one is, I have taken Janaki Ammal. Okay, so today, since we are actually celebrating Science Day and with the theme Women in Science, okay, so she's a Janaki Ammal. So, and she is from a very, poor family from Kerala, okay, and also she was from a very, low social background, okay, so during 1920, okay, she took up the field of science, okay, so during that days, you all know, there was no encouragement for taking up science at all, and also on the other hand, women taking up the science, still today it is there, but during that time, 1920, women taking up the science was very, very difficult, but still she took up, she dared to took up the, field of science, not because it was fashionable, not because, it was attractive or something like that, because of her curiosity about the, plants. Okay, so because of that curiosity, so she took up this, field of science. And again, this is also an example. So whenever you have curiosity, okay, so when you get curiosity about the nature, or when you get a proper questioning, or whenever you want to understand the nature properly, okay, so science comes into picture, not the technology. Okay, so science is very, very important. So she worked on the I think it has to go to the full screen mode. Okay, so yeah. She worked on the botanical path. She has also, worked on cytogenetics and hybridization. So she has developed a very different variety of sugar cane. Okay, so which was giving very good yield. Okay, so that was her work, and it was also commendable. But when you see your, history of science, so we never see Janaki Ammal, right? So we'll always see, the male personalities or male scientists very well. But I too was not aware of Janaki Ammal, but she was there in the history. Okay, so she has created a model of quiet, steady excellence, and she was, I mean, she went to abroad to do her PhD. That was also very important. During that days, she dared to go abroad and she done her PhD and she came back to India, and whatever her research was not so easy. So her path was very, very difficult, but still she didn't lost her motivation. So she was very stubborn and she did all these things. Okay, so that's why we have, I mean, very good name for Janaki Ammal in the history. So yeah, so she is a Janaki Ammal and her picture. Okay, yeah. So then the question is, so with these two examples, so we have to ask one question: what is science? Okay, so what is science? It is a disciplined method of inquiry. Okay, so it's a disciplined method of inquiry. So whenever you inquire a particular thing with what I can say, very good basics. Okay, so then only you can understand what is science. So I mean, science is not just a facts, or it is not just series of experiments we are going to perform. Okay, so it is about a rigorous way of questioning. Okay, so with the experiments, we should understand the facts. With the facts, we should again question. Okay, and also we have to share principles across disciplines. So nowadays, I mean, if you ask me what is science, I can't say it's just physics. It is not just chemistry or biology or something like that. It is across disciplines. That's why I'm talking about science rather than just physics. Okay, so when you share the principles or the ideas across the disciplines, okay, so then only you can understand what is, I mean, science. Okay, so here from the past two examples, you can see Raman, who has done optical physics, Ammal, who has done cytogenetics. Okay, so what is the common method? So common method was like performing experiments in their particular fields, in the physics and in the chemistry, and also, I mean, adopting proper methods. So he came out with the results in the physics, but she came out with the results in the biology. Okay, so the scientific observation or whatever the scientific process is, so first of all you should observe, okay, what are the noticing patterns or the anomalies. Okay, so first of all you should question. So as Raman questioned, like why the color of the ocean or the water is blue, and then you should come out with the hypothesis should be grounded and it should have logical explanation, and also you should have a control testing and the measurements, that is about the experimentation, and then you have to analyze the data which you get out of this experimentation, and you should have a proper interpretation, and that is called as the quantification, and finally you should have claims which must be testable. So if you are coming out with the result and if you say no, my results are the ultimate, so it is not science. Okay, so the results should be testable, and that is why we will say it should be falsifiable. Okay, so that means my results can be made false, or it can be proved false by some other people. Okay, so then only it can become a science. Okay, so science is not just information. It is not limited to laboratories, and it is not a privilege at all. Okay, so science is discipline questioning, as I already told you, and it's evidence-based reasoning, intellectual. It should have intellectual courage and methodological rigor. Okay, so that is why I can say that science is a way of thinking about reality. So only by science we can understand the reality. You all know, right? Because people are conducting many experiments to unravel the nature. So there are many questions like how this universe has originated. Okay, so that's a Big Bang theory. Okay, so still people are working for it, and many models are there, but still we are not able to come out with the proper theory for this Big Bang, which can be experimentally tested. That's why people are constructing larger accelerators, that is Large Hadron Collider in Geneva, to test that particular theory. And also you all know black holes are there, right? And also you know gravitational waves have been recently discovered, and people are still trying to write quantum gravitational theory. So all these things are like about a way of thinking about reality. That is a science. Okay. Yeah. Yeah. So if I talk about what is the evolution of scientific thought, as I told you, so science according to the Karl Popper, so it should be falsifiable. Okay, so that means whatever the theory you are going to come out. So you see, in science, we cannot say I have discovered something, I have invented something. So how do you prove your invention or the discovery? So it has to be, I mean, like written in form of a research paper, or you should go for the patent or something like that. Then only it will be tested in many ways. And after the testing, if your results are going to be proved like repeatable and I mean like scientifically valid, then only it will be considered as a discovery or whatever the invention. So otherwise, if you say I have invented something, so nobody is going to believe that. Okay. So there will be a like I mean series of tests. Okay, so suppose if it is a I mean scientific theory, so the claims whatever going to be must be testable, and science progresses by surviving disproof. Okay, so if somebody, yeah, we have actually understood physics by classical mechanics till 1900. Okay, so after that some experimental results were not able to explain by the classical mechanics. Then came the, I mean, modern physics or the quantum theory. Okay, so quantum theory actually established the limit, actually told there is a limitation to classical mechanics. Okay, so it's not a, I mean, a completely invalid theory, rather it is having a limitation. And then came the quantum theory, and we had a success. Okay, so after quantum theory we have relativistic quantum theory, after that we have quantum field theory. Because of their limitations, many theories have been evolved. That is because, so whenever you have a scientific theory, so you always look for the experimental evidence. Okay, so we are not going to, I mean, like just believe it by its own successful mathematical model. So it will be tested, and also, I mean, claims must be tested. It should be stable in the method. If you measure here or in somewhere else, in US or Europe or something like that, measurements should give the same results. And also scientific paradigms. Okay, so there will be always a shift in the paradigms. Okay, so that means understanding. Okay, so as I told you, there will be there was a scientific shift in the, I mean, paradigm shift in the scientific invention from classical to the quantum. Okay, quantum to the next, I mean, special theory of relativity to the general theory of relativity. So like that, there will be always a paradigm shift in the development of science. So then why do we need science? Why do we need science even though we are already technologically advanced, right? So we have to, I mean, so much of technological advance. So why do we need science beyond the technology? So we always say that we need science for all these things, because you all know these are all scientific inventions only: electricity, vaccines, internet, space missions, etc. But this is not the end. Okay, so because today's science is 20 years technology, you all know that. If science stops today, after 20 years, technology also stops. So there should be a continuous innovations or the research in the scientific field. Then only technology is also going to progress. So that is why science is not, I mean, we cannot say, okay, we have done everything and let's stop science and we'll only focus on the technology. Okay, after some time, you're going to see, so there is a, I mean, lack in the, I mean, research area. So basic research area. Okay, so what is the deeper reason for the having a, I mean, science? So the deeper reason is, you know that humans are evolved only for survival, okay, not for the truth. So we always, I mean, adopt survival strategies, okay, so to live, okay. And we cannot see atoms, right? So we'll see whatever is visible to our light, and we cannot see. Only science will give the evidence of atoms. Nobody can see the atoms, right? So we'll get only the evidence. And also nobody will see electromagnetic waves. Okay, so except the light. Light also can't be seen, right? And also nobody can give, or I mean, humans cannot get a direct evidence. Okay, so for the quantum probability. Okay, so therefore, only the science will give you, possibilities of to feel all these things. Okay, so yeah, and science will extend our senses. Okay, so how? So without science, what we'll do will be like we'll believe what people are going to say. Okay, so without experimental evidence, scientists will never believe what people will say. They will, ask for the experimental results or the evidences. So if we don't have science, we'll have confirmation bias, anecdotal reasoning, and authority dependence. So if somebody says, like some principal of the college, if he says something, if he or she, so we should believe it. Okay, so without science, but within science, we don't do such things. Okay, so science actually, excuse me. Sorry. Yeah. So, but science counter biases with the replication of the results, right? So people will not believe. So they will replicate the results. They will do the experiments repeatedly. And also whatever we are going to come out with the results will go to the peer review. And also it will be undergone statistical testing. And also there will be a transparency in implementing the results. Okay. So that is why science is very much essential. Okay, so once, Richard Feynman, who is a famous physicist and also is a very good professor of physics, he told, the first principle is that you must not fool yourself and you are the easiest person to fool. Sometimes we will get, like false results, spurious results or something like that. So in science, we are not going to report the results which we get for the first time. What we'll do is we'll validate the results. We'll repeat the experiments. And if we'll repeat it in different time scales also. So then if you are getting, same results within some experimental uncertainties or the errors, we are going to report. And when we report and when it is going to be peer reviewed, it will be tested by even it will be checked by the experts in that domain. Okay, so they will also question at many levels. Okay, so after answering all those questions, so the paper is going to be accepted, or our work is going to be received in the scientific fraternity. So therefore, so he says on the first principle, you don't fool yourself. Okay, so and you are the easiest person to fool. So you don't believe your results unless it's going to be tested many times. That is what Richard Feynman says. Okay. Science actually prevents us from fooling ourselves. So don't fool yourself. So you go by the scientific evidences, experimental results. Okay, so that is a thing. And also if we come to the history of science, okay. So if we see the history of science, we can say that if science is a method, how did humanity discover this method? So earlier, if you see the history of science, during the very early days, maybe during 1500, 2600 or something like that. So people used to, see all the planets are going to be moving, right? So they could see sun moving from east to west and also even the moon. Okay, so they are also they used to see all the stars in the sky and other things. Okay, so whenever, they used to have some philosophy behind understanding these motions. Okay, so not the scientific way of understanding, but they had some philosophy. You all know the Aristotle, right? So Aristotle had a greater philosophy to explain all these things. And also I have read somewhere that if some comets are going to pass and if some king is going to win some battle or something like that, they used to relate. Even if he lost, they used to relate with something else. So that is also some type of superstitious beliefs. Okay. So since there was no valid theories, valid science, which has been tested experimentally to explain these things, they used to believe it philosophically. So that was the earlier scenario. Okay, so as I told you, Aristotle used to explain all these things. Motion by natural places and purposes. Heavy objects seek natural place. Motion needs continuous force. And speed is proportional to weight. All these things were like just philosophical, since there were not proper theories. Okay. So the turning point was when Galileo Galilei. Okay, so he actually, started explaining the things with the, valid experiments. Okay, so he measured motion and time and also used inclined planes and water claws, and also he discovered S is proportional to T square. So all these things were started tested by some experiments. Okay, and also, before in the, in the history of science, so alchemy and speculation. Okay, so this phenomenology was dominated, reactions were observed, not explained, just they were used to observe, and combustion was, what is the phlogiston release. Okay, so there was some like philosophical explanation for chemical processes also. Okay, so after the quantitative chemistry, you all know the progress in the, chemistry, like John Dalton's atomic theory and also Anton Lavoisier. Okay, so then they started thinking about these scientific issues, or they thought they started thinking scientifically. Okay, so law of defined proportions and law of multiple proportions, precise mass measurements and all. And after that, they accepted based on measurement and not the speculations. Okay, so evidence actually explains nature even when we cannot see the entities. So we will look into the evidences. Okay, so not the speculations. Okay, so and also, if you see the biology, okay, so how people were used to understand the diseases. So they used to understand the diseases by imbalance in the humors, air polluted by the miasma, and bloodletting and superstition. Okay, so something, it's going to be connected with the superstitious beliefs. Okay, so after that, you have seen that there was a breakthrough. Okay, so there was a germ theory of disease. Okay, so that was established by the Louis Pasteur. Okay, so he told germs cause specific diseases. Germs in the air will cause the disease. And there was a, experiment which has been established for this casualty, and the living systems can be understood scientifically. Okay, so we can see invisible things. Okay, so science makes invisible things visible through the instruments. So then there was a discovery of microscopes. They could see these germs, and also they can, they come out with the proper reason for falling ill. Okay, so yeah. So again, if you see the history, okay, so the Darwinian, theory, you all know the Darwinian theory, how universe have been evoluted, right? So how people have explained in the old ages, so they used to believe that God has made one man and woman, and later, this entire generation has happened. So what's the Darwin's theory? So where is our origin? Our origin is from the monkeys, right? So that was a Darwin theory. So we didn't, believed it, right? So we had a proper experimental evidences for all these things. Okay, so through the proper experimental evidences, we have, believed that. Okay, so as I was telling you, there was a quantum and relativity revolutions were also there. Okay, so Newton was the first person to write the mathematical equations to explain the mechanics, the whole mechanics. After that, people see that is not sufficient. So came out with the, Lagrangian and Hamiltonian equations. And after that, we were seeing Max Planck has explained the dual nature of the light, right? Light sometimes behaves as a particle, electromagnetic radiations behaves like a particle as well as waves. And based on the Max Planck theory, so we could see the explanation for the black body spectrum, and that was the origin of the quantum mechanics. And Einstein also used, Planck's hypothesis and explained photoelectric effect. And also he came out with a very important relation between the energy and the mass, that is equal to mc square. Right? So there actually, and also Newtonian mechanics could not explain the motion of the bodies which travel with a very larger velocity. And also we came to the understanding that velocity of light is ultimate and it is the highest in this universe. And Einstein wrote a special theory of relativity in order to explain the larger particles which are moving with a very larger speed. And again, he himself
actually tested his theory and he was not able to include gravitation into the special theory of relativity, and he came out with the general theory of relativity. And here I should mention, even though he has written, very complicated special theory as well as general theory of relativity, he could get the Nobel Prize for explaining the Einstein's, photoelectric effect by using Max Planck's hypothesis. Okay, so he was not able to get the Nobel Prize for the complicated theories, but he could get the Nobel Prize for this, which was very, very important because it was played a historical role in establishing the birth of quantum mechanics. Okay, yeah. And also after that, we can see that de Broglie actually identified dual nature of the particles also. So he has identified particles also will show up the wave nature, and that is why he has assigned a wave function, and then Schrodinger equation came into picture, and also the Heisenberg, and all these people are, actually explained these things. Okay, so, and if you see history of science, you all know that mathematics is a bone or is a mother of science, right? Without mathematics, we cannot understand anything, including biology. Okay, so today's biology at the molecular level can be better understood by using physics and mathematics, and not by the biology itself. Okay, so there was a development in the history of mathematics also. So actually there were many complicated theory. There were non-Euclidean theory, then Euclidean theory, and many other theories were actually, came into existence. Because of the development of mathematics only, we could have different theories in physics. Okay, so otherwise, physics cannot be done with the mathematics. Mathematical, development led to the different theories. Okay, so yeah, so there was a great transformation. Okay, so as we see the science, okay, yeah. So here you can see that myth has been changed to the measurement. Authority is also changed to the experiment. So these are going to be the authority. Experiment is the authority. Certainty has changed to probability. So, and isolation has been changed to the collaboration. So without collaboration, we are not able to do any experiments or we cannot come out with any greater results these days. And also the science manifestation is not dogma, but it is skepticism. Okay, so authority yields to evidence failures, and which leads to the insight. Suppose if you have come out with one theory, and if somebody is doubting it, you are going to get a better theory. It is not that there is a failure in that theory, rather we are going to get a better theory out of it, since we are going to question. Okay, so the evolutionary stages is actually from the observation. So we have to take up the measurement, and then the maths comes into picture, and revolution, and then the abstraction. Okay, so that is going to be the, that is how we are going to do the science today. Okay, so there should be a continuity between these 4 stages. Then only we can do the science. So yeah, modern, sorry. Lena? Yes. So as I was telling you, so when you are going to publish a paper, okay, so this is going to be the cycle. Okay, so self-correction and the peer review. So how do you start with the, any research? The research is doing science itself. So you will start with the curiosity in the question, and then it will go to the publication, peer review, independent verification, replication claim, and stress tested, and doubt is going to be cleared. Okay, so everything is going to be cleared, then you're going to have a publication in your hand. Okay, and also these days we cannot do any research in any particular area, because interdisciplinary boundaries is very important in the climate research. Routinely, that's very important, and also that is going to integrate the fields that's like computational biology, engineering, physics, statistics. And these days you all know computation field has taken over the major part of the research. Okay, so not just doing computer science or some computer coding, computational methods are beyond that. Okay, so it requires understanding of the science also. So yeah, and ethical compass responsibility. Suppose if you want to do I mean, if you want to claim that I have done something which is going to be very novel and that is your discovery or something like that. So these days we call it as a patent. Okay, so the very big, small discoveries are can be patented. Okay, so that's also should be ethically tested. Okay, so the modern science which we are now is should be iterative, computational, collective, and precision driven. Okay, so yeah, these are the stages of research. Okay, so curiosity driven questioning. So either you use mathematical computational modeling, experimental validation, simulation, statistical inference, and it's going to be done along with the collaboration across institutions. And then you go to the peer review, public communication, ethical reflection, and then continuous revision will again answer your curiosity driven questioning. Okay, so that is how the research goes. Okay, so since today's theme is women in science, so let me tell you what is the status of women in science in India at least. We all know that even I can see more than half of the hall is women. Okay, so that is a picture in undergraduate level. Okay, so 43% of the STEM graduates. Okay, so scientific, technological, and engineering. Okay, so these graduates, 43% are the women graduates. But when we pass through different stages, okay, so you will experience social expectations and caregiving burdens, mobility constraints, unconscious bias, and also limited institutional support. So it is called as a leaky pipeline. Okay, so everything it's going to leak out. This 43% is going to leak out, and you are going to get some 6% at the final stage. So doctoral research, there will be less women students we can see. So, okay, we can also see some major amount of women students at the doctoral also. After that, postdoctoral, we'll see very less students, and after that, faculty positions, very less. And when it comes to the leadership roles, women are the, very, very less in the, top positions. Okay. So despite all these barriers, okay, so we can see some very, very good women scientists who are working both in the technological level, scientific level, and even the engineering level. So if you see, I think recently you have seen the Chandrayaan, right? So in that you could see many women scientists, right? So I could also see in the newspaper. Okay, so if science is the pursuit of truth, true evidence, then exclusion within science itself is a distortion of the truth. We should not exclude, rather we should include. Inclusion should be there, because we don't know if we include many minds. Okay, so it's just including the minds, and we don't know what are the different thought process of different minds, and maybe some novel ideas are going to be, emerged out of the women scientists also. So therefore, it should be inclusion rather than exclusion. So suppose if we take Indian pioneers and contemporary leaders who are playing a major role in the women, in the scientific field. Okay, so you can see that there are many women who are working in the aerospace and missile systems. Dr. Tessie Thomas. Okay, so she is working in the aerospace. So her work actually strengthened ring laser gyro systems, micro navigation modules, advanced Kalman filter based correction. So it is not my intention to explain each and everything, rather to give you a picture that many women scientists. So if you ask me whether those women scientists are not having any barriers, so they also have barriers, but they have overcome those barriers. If you overcome, then only you can do something. Otherwise, you will be lost in those barriers itself. Okay. So she is the, Dr. Tessie Thomas. So this is her pictures, and also Dr. Ritu Karidhar. Okay. So she has, worked in modern India, the Mars Challenge. Okay. So she has worked in the Mars project. and she has contributed in many ways to this particular project, and she is her. And in the biomedical science and vaccine research, Gangadeep Kang. So she has, given a contributions. So moving from Western assumptions to India-specific immunological data, and that has solved the vaccine paradox. Okay, and she has came out with the, new vaccines, the invention of new vaccines. Okay, so Gangadeep Kang, this is her real pictures. And in the experimental particle physics, Biba Chaudhary. Okay, so she has contributed a lot in the, experimental particle physics field. So she has done cloud chamber photographic track analysis and identification of heavy particle tracks, meson. Okay, so mesons she has identified, statistical classification of cosmic ray events, and that has contributed to the early research of mesons. So she has also done many things, and it is her picture. And in the organic and medical chemistry, Asima Chatterjee. I think you have heard her name, right? So she has contributed in isolating active alkaloids from the indigenous plants, and she used chromographic separation techniques, and that has contributed in medicinal field. This is her picture. And in the immunology and disease spectrum, Indira Nath. Okay, so she has contributed to T cell mediated immune responses. She measured cytokine production differences and all these things. Okay, so she has also contributed, and this is her real picture. And in the meteorology and instrumentation, Annamani. So she has standardized radiation instruments and developed calibration systems, and also developed, she created reliable atmospheric measurement protocols. Okay, so she has worked in that field, and it is her pictures. And in the mathematical epidemiology, Sunetra Gupta. Okay, so she has created models which needed to embrace strain evolution and the diversity of immunity. So she created the mathematical models, and this is her pictures. Yeah. So in the fundamental physics, Rohini Godbole, I think I have heard, I have seen and I have heard her lectures also. So she has, contributed in the high energy theoretical physics. So she was saying always she was contributed in identifying the quarks. Okay, so she was always telling that, and she has also contributed, and this is her real picture. And in the fundamental condensed matter physics, Archana Sharma, she has contributed, and she has worked on the gas electron multiplier detector, and this amplify electron signals generated by passing charged particles. So you can see many scientists. So in the pure mathematics, so algebra and number theory, so you can see Neena Gupta. So she has also contributed in the, constructed a counter example in positive characteristic, and it requires deep commutative algebra, affine algebraic geometry, polynomial ring analysis. So ring theories and field theories are very difficult theories. And this is a real picture. Yeah, next. Yeah. So sociology and inequality studies, Leela Dubey. So she has also, contributed to science. So this is a real picture. And so when we want to have what is today's theme? So women in science, catalyzing Viksit Bharat, right? So in order to have a Viksit Bharat, okay, spelling mistake. So we should have a intellectual inclusion. Okay, so we should have an inclusion. So we should have contribution in the every layer of the science. Okay, from the women. Okay, so we know there are unresolved structural barriers, so which actually limit the inclusion of the women into the science. But if we encourage, okay, so if we encourage, what are the barriers? Casual interference for structural bias, cause and effect arrows, isolating biases. So many things are there. Okay, so if we overcome all these things, so we can have scientific advancement, and that will have a greater national impact. Okay, so let me conclude my talk. So I think I have given you enough information about like how we can have a scientific temper by questioning the fundamental questions, or by having a fundamental questions, or getting having a curiosity to know the nature. Okay, so that is very, very important. And also I have shown you why science is needed. Okay, so how we have traveled from the philosophical way of understanding to the questioning. Okay, and also I have told you, even though we have many, many barriers for women to enter the science field, so many women are actually contributing silently to the development of the science. But this year government has even identified the importance of the inclusion. Okay, so inclusion of women into the science, so that we can have a great deal, which actually helps us in towards the Viksit Bharat. Okay, so space and defense, healthcare and biotech. So there are many, many fields. So many of you are here from the science background, so you can choose whatever the field which is going to create curiosity in your mind. Okay, questioning in your mind, and you can choose these things, and any of these fields, space and defense, healthcare, the philosophical core, and also agriculture and food security, energy and digital field. Okay, so science is actually a structured problem solving at a scale and the architecture of modern civilization. So by asking questions, you can come out with the answers. Okay, so by answering those questions, you can even contribute to the Viksit Bharat, or the development of the nation. Okay, thank you very much. Yeah. No idea. So if you have any questions, you can ask me.
Thank you, ma'am. Proceeding further, gratitude is the memory of the heart. To conclude the formal proceedings and thank everyone who made this day possible, I invite Farooq from second year BSc for the vote of thanks. Over to you, Farooq.
Good afternoon to one and all present here. It is my proud privilege to propose the vote of thanks on this special occasion. First and foremost, I express our heartfelt gratitude to our esteemed resource person, Dr. Krishnaveni S., Professor of Physics, University of Mysore, for valuable presence. Thank you, ma'am. I extend my sincere thanks to our respected Reverend Dr. Luth Prasad Joseph in their absence, Rector, for his constant encouragement and support in organizing this program. Thank you, Father. I also grateful acknowledge the gracious presence of Reverend Father Gnana Prakasham in their absence, Campus Administrator and Reverend Father David Chagairaj S. in their absence, Assistant to the Rector, for their supportive which add great strength to this event. Thank you, Father. My heartfelt thanks to our respected Principal Dr. Rabi J.D. Saldana in their absence for his continuous motivation and leadership that inspire us in achieve excellence. Thank you, sir. I would also like to thank our Vice Principal Administration, Mr. Ronald Prakash Kutina, in their absence and for his valuable support and coordination. Thank you, sir. I would also like to thank Mr. R. Brito Dominic Ryan, HOD of Chemistry and Dean of Science, in their absence for his encouragement and efforts in making this program a success. Thank you, sir. A heartfelt thanks to Mr. A. Thomas Gunasilan, HOD of Physics UG, IQAC Coordinator and Convener of this program, and Dr. Sachin CN, HOD of Physics Department PG and Coordinator of this program, for their invaluable support and dedication for the success of this program. Thank you, teachers. A heartfelt thanks to Dr. Deepa V, co-coordinator of this program, and of their invaluable support and dedication for the success of this program. Thank you, ma'am. Special thanks to Mr. William Joseph and Dr. Shivaraju in their absence for evaluating the essay scripts. Thank you, teachers. I extend my appreciation to one and all organizing committee members, staffs, supporting staffs, helped in organizing, and students whose hard work and dedication made this event possible. Last but not least, I thank each and every one of you for your active participation and presence. Thank you once again to one and all.
Thank you so much, Faru. There's an announcement. Working model making competition will be held on 14th of March. I'm so sorry. Okay. Working model making competition will be held on 14 March 2026, and the theme followed will be general science, and it is an open invitation. The interested students are required to register the names to Chandana ma'am. All right. Concluding the program, on behalf of the organizing committee and departments of physics, I, Hudas from second year BSc, thank you all for being a part of this inspiring celebration. Now it's time for the national anthem. I request everyone to kindly rise for the national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उज्जल जगति तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे ये तव जय गाथा गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you everyone for being part of this program.